Hello, you are welcome. In this video, we are going to solve this exponential problem. We have t to the power of t and this equals 7. We are solving for the value of t that will satisfy this equation. Now, I know you might want to test for that value of t that will satisfy this equation. Now, for instance, if you substitute 1, let's say if t equals 1, maybe you just want to test. If you substitute this 1 for t, you are going to have 1 to the power of 1, and this is not equal to 7. So even if you go ahead and substitute 2, you have 2 to the power of 2, because whatever number you have here, it must be the same number you have at the exponent, because the t you have here is exactly the t that you are having here. So whatever your number you are having here must be the same at the exponent. And once you have 2 power 2, this will also not give you 7. Now you proceed to 3, you have if t equals 3, you are going to have 3 to the power of 3, and this is not also 7. In fact, 3 to the power of 3 gives you 27, and 2 to the power of 2 gives you 4. Now, what number are we looking at here? We are looking at 7. This is 4 and this is 27. So, the number that we are looking for is between 2 and 3, because 2 to the power of 2 gives us 4 and 3 to the power of 3 gives us 27. So the answer that we are looking for is between 2 and 3. So it falls between this range. And if you continue to test, maybe you continue testing 2.1, 2.2, 2.3, before you get to 3, you must actually have gotten the value. But we cannot be wasting that time. There's a way of actually solving this particular problem, and that is what we are going to do right now. So let's have our solution, and we are going to start by using natural log. We have ln of t to the power of t, and this equals ln of 7. So we proceed according to logarithm property. If you have log of a to the power of b, this equals b times log of a. So we apply the same property right here. That means we are going to have t times ln of t, and this equals ln of 7. Now we need to solve this particular equation, and there's only one method of solving it for now. It is by the use of what we call the Lambert W function. And here is it. The Lambert W function is represented as, if you have the Lambert W function of a function such as this, a times e power of a, this will give you a. So whenever you have an expression such as this, a times e power of a, you can apply the Lambert W function right there. And once you apply it, what you are going to get will be this exponent, which is the a. So that is the meaning of this function. So if you have an expression such as this, let me make use of another one. If you have x times e power of x, then you go ahead and apply the Lambert W function using this w to represent it. That means what you are going to get is x. So the idea right now is you must make sure that this expression that we are having here is in the form of a times e power of a, or x times e power of x. Even if you apply the same function, maybe you have the Lambert W function of maybe a phone. Let's have a phone here, something like this, times e power a phone. You have a phone like this. What you are going to get will be a phone. You have a phone like this. So this particular function is very powerful as far as this expression you are having here is in the form of a times e power of a, or x times e power of x, or a phone times e power of a phone. So what we are going to do now is to manipulate this. We are going to manipulate this to be in the form of a times e power of a. And for us to do that, this is it. This is the trick. So you pay attention right now. We have t times ln of t, and this equals ln of 7. I've just copied this down here. Now, if you have e power ln of x, do you know that this is the same as x? Because e here will eliminate the ln here, and you are going to have x left. E can actually eliminate the ln, so what you are going to have is x. So we are going to replace this t here with e power ln of t. So that is the secret of actually expressing this in this particular form. So what we are going to do right now is, instead of this t, we are going to have e to the power of ln of t, because this e will eliminate this natural log, and you are going to have your t again. We haven't changed anything. Then we have times here ln of t, and this equals ln of what? 7. So we proceed again. Now the next thing we are going to do is we can rearrange it, because we can write this first, ln of t first, before e power ln of t, because what we had here is a before e power a. So let's do the same thing here. We have ln of t times e power ln of t, and this equals ln of 7. Gradually we are getting to this particular expression. Now at this point, what we have here is exactly what we have here. So we can apply the Lambert W function now. So we have the Lambert W function of ln of t times e power ln of t, and this equals, we also need to apply it here, Lambert W function of ln of what? 7. So based on this particular trick, if you apply the Lambert W function of x times e power of x, what you are getting is x. Lambert W function of a phone times e power of a phone, you are getting a phone. That means the Lambert W function of ln of t times e power ln of t, you are going to have ln of t, and this equals the Lambert W function of ln of what? 7. So we proceed again. Now we need to eliminate this ln here, and for us to do that, we introduce e again. So we can take e power ln of t, and this equals, we take the e again, e power the Lambert W function of ln of what? 7. Now what will happen here is this e here will eliminate this ln, and what you are going to have left here is simply t. So that means your t equals e power the Lambert W function of ln of 7, and this becomes your final answer. Are you surprised? Guys, here is the answer, but if you need some values, because we are actually solving for a value of t that will satisfy this equation, this is what you are going to do. You simply have your t equals, you type in this into your calculator, you have e to the power of, instead of this Lambert W function, you may not see it here in your calculator, you may not see this Lambert W function in your calculator. What you are going to see is product log. That's what you are going to see. You have product log of ln of 7. Sincerely, if you type in this into your calculator, we are going to have a value for t, and that value is simply 2.3165 into 4 decimal places, and this becomes the value of t that will satisfy that equation. As simple as that. Now our value for t is 2.3165. So if you come over here and have 2.3165 raised to the power of 2.3165. You are going to have an approximate value of 7. So guys, that is it, and that is the end of the video. I believe you enjoyed this video. Please don't forget to subscribe and share. Thank you and goodbye.